In today's video, we're taking a look at the difference between full batteries and batteries that have been drained of all of their juices. How are they different and how can you easily tell them apart? We've got a bunch of batteries. So far, these batteries are in good condition, but we want to do some tests to see what's different between a fully charged battery and a fully drained battery. And we want to see if we can figure out how you can tell the difference between the two.
Here's the basic idea. We have seen that you can bounce batteries to tell whether or not they are charged. So we're going to try that, see what's different, and then try a few other tests as well.
First step is we need to drain power out of these. So I've got a flashlight. When I bought it on the packaging, it said that it gave like 2.5 hours of light. And so I figured we can put the battery in there, see how dim the flashlight gets, and then take it out and see how much worse it is.
After that, we're going to put batteries in for progressively smaller increments of time to see if we can get a perfect scale of a fully charged battery to a fully dead battery and see what the differences are.
So we've got batteries in this flashlight, and now what we want to do is just let it sit for a long time. We want to drain all of the power out of these batteries. All right, we have now taken batteries and we have drained them a lot. We actually had one set of batteries we left in overnight to really try and drain them off. And that wasn't even necessarily quite enough. So we then took those batteries and we put them into a remote control car and left it running to try and drain them even more. Other than that, we have batteries at 15-minute increments from 2 hours and 15 minutes all the way down to none.
So first thing, I want to try that bounce test. Everybody says that you can bounce the batteries and a perfectly charged battery isn't going to bounce, and the one that's pretty close to empty is going to have a lot more bounce to it.
First thing I want to do is just holding it over a counter and dropping it the same way anyone would if they're pulling batteries out of a junk drawer and they're not sure, like, oh, is this a good battery, is this a bad battery? This is supposed to be the super easy way to test. If this works at all, I want to scale it up and have just a whole setup that will drop all of the batteries at once from fully charged to completely drained and see if we can get them to just bounce in a nice little array. But first, let's try the I just found the battery in a junk drawer test.
So the one at 2 hours, 15 minutes, quite a bit of bounce to it. Or the one that's fully charged, it's like the One Ring. There's no bounce. Editors, can we put in a clip of the One Ring hitting the ground, please? So I want to know if there's a weight difference. They don't feel any different to me, but that doesn't mean that it's not there.
As far as I can tell, just holding them, they feel the same. I'm just trying to see, like, is there any slight bowing or change in like how flat any parts of it are? I really am not seeing anything, so I don't think that's changed. And I think that's intentional. They don't want the battery to distort as you use it. We have a very sensitive scale. This thing is designed for measuring gunpowder, and we've got it set to grams right now. So let's do a test. All right, let's get one of our fully charged batteries.
There we go.
It's fully charged?
Fully charged. No marks on it.
24.4. 24.45. 24.25. So we do have a little bit of variation here. Almost all of these batteries are from one package. They all came together, and you can see that they actually say USA printed on the top.
Yeah.
These two batteries came with the flashlight, and they do not have USA printed at the top of them, so they are slightly different in some way.
So this is the one that we just tried the bounce test with. This is at 2 hours, 15 minutes of use.
24.25. Now that would be exactly the same as the full battery from this same batch.
That's true.
Also 2 hours and 15 minutes, just the other one. 24.35, still very much within that same range. Yeah, grab a one in the middle and see what you get.
30 minutes.
24.4. So I'm gonna say the weight, and I didn't think the weight was gonna change. Nothing is escaping, nothing's leaving the battery as you're using it. And so the mass is the same. It's not gonna be any different. Even though I was pretty sure that was the case, I did want to test because maybe something was escaping, but it seems that the mass is unchanged. We've now had these three batteries running our remote control car for a little bit after they ran the flashlight for a long time. So these two batteries were in the flashlight overnight, and then to really try and drain them the rest of the way, we threw them into this remote control car and drove that around. 0% batteries versus full battery. We've already done a bounce test, and we've seen that our full battery will not bounce, whereas our empty battery will. Not bad. So empty, also empty, full. Let's take our voltmeter and test it on the batteries to see how much power each of these has. First off, a full battery. Okay, we are getting a reading of 1.6 volts, almost exactly, just a hair over, 1.6 volts. Now our drain batteries, this is as dead as we can get it. We are looking at 0.981. So that's not zero. It's not showing that there's no power left in this battery.
But in the RC car, this wasn't working anymore. So a dead battery actually still has over half of what a battery has initially.
In terms of voltage, at least.
Yeah.
Now, how well that translates into usable power probably depends on what device you're using. If I put these two dead batteries in our flashlight, we're still getting light out of the flashlight. And so it's not 100% drained, clearly, but in something like the RC car, it needs a little bit more power, especially if the wheels are actually in contact with the ground. It can barely overcome the coefficient of static friction to get this thing moving. For the most part, it just like limps along at 1/4 of a mile an hour, whereas with full batteries, it actually kind of zooms around a little bit. Full battery, 1.6-ish volts.
A little more.
Empty battery,
0.9.
0.98 volts. Here's one that was in the flashlight for only 15 minutes. 1.476. So that's a quick drop off.
Yeah, I would not have expected
in
that
only
much.
15 minutes, it goes from 1.6 to 1.47. Like that's just, phew. We've tried weighing the batteries and now we've used a voltmeter, and we can definitely tell with the voltmeter what's a good fresh battery and what's been used, and it drops off pretty quick. I was surprised at how fast.
So after 15 minutes, you can already see that you've got a 0.2 drop in it. That's kind of insane given the fact that at the end of running something in a car until it would no longer go anywhere, it was 0.98.
Yeah, it's clearly not a linear scale for using the voltage in a battery. It drops off very quickly at first and then levels out quite a bit. We had to run these batteries for a long time to get them below 1 volt. We've got some masonite, we've got a board, and we've got some strips. And we are just gonna glue all these strips on at least one battery wide, so we can then have just sort of a rail system. And all of these batteries will just fall down next to each other, and we can get a good shot, a test of the batteries in line from a completely charged battery to a completely discharged battery.
Zoom, zoom. Pew, pew, pew. Zoom, zoom. Pew, 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 pew.
Here's our battery track. In theory, we should be able to take a battery and drop it. It worked, it dropped. Fell all the way down with pretty much no resistance. That's the goal right there. We've got our battery rail box set up, and hopefully the automatic drop system all works smoothly. Let's give this a test. Our batteries are currently in line from fully charged to very much depleted. 3, 2, 1.
That was cool.
It was cool. They didn't all hit the ground at the same time.
He didn't. That's really cool.
Yeah,
those
that looked good. Like once we can actually get it to go all at the right speed.
I think it's gonna work.
I think so. We were having just a little bit of trouble getting all of the batteries to drop at the same time. I think they were sticking a little bit to the paint. And so we actually just added some cornstarch on the inside to sort of a dry lubricant. And
it's gonna be a little powdery, but I think it's gonna work a little bit better.
Yeah, it should be good. All right, 3, 2, 1.
From a higher spot this time.
Oh no. 3, 2, 1.
A little,
Yeah.
It like hits it. That's
No,
it.
oh, one of them fully jumped up out of the frame.
Ooh.
Guys, that's not all. We've always got more for you. To see that box up at the top is going to take you to our last video. You should go check that out. The other box is going to show you what YouTube thinks you should be watching next. And if you hit this bomb here in the middle, you'll be subscribed to the channel, and that way you're never going to miss a cool video. Don't forget to ring that bell, and we'll see you in the next one. Talk to you then.